Now I'm very happy to introduce Rafael Banchs. Rafael is an adjunct professor at Nanyang Technological University in Singapore, where he previously was a research scientist at the Institute of Infocom Research. Rafael has focused in his research on applying innovative methods and NLP technologies to problems in the service industry, and he supervises student projects in question answering and conversational agents related to applications at NTT. Rafael is very known for his work on conversational agents and dialogue systems, natural language applications like machine translation, information retrieval, and NLP. And he has experience also organizing workshops at ACL and other international conferences, including IWSDS 2 years ago in Singapore. And he has also organized several workshop series like named entities like news, conversational agents, WoChat, for instance, later in this IWSDS, and machine translation like Hydra. And just recently, John Hopkins chat to dialogue modeling and evaluation summer school. So today, Rafael will guide us to an epic journey across the seas of data and data-driven applications to finding Nemo, sorry, not Nemo, but NEMD, the new evaluation metrics for dialogues. So I'm very happy and excited to hear about how to tame the conversational AI creatures for the benefit of science and humankind. So Rafael, please, can you share your screen?
Well, thank you so much for the introduction, Kristiina. And thank you so much to Luis and Soraya and the rest of the organizing committee for this invitation. For me, it's an honor and a privilege to be able to present some of my thoughts about these topics here at IWSDS. I regret a lot that the meeting was not able to be in person. I mean, going to Madrid is always for me a great experience. And an opportunity to visit a lot of friends and family there. So let me share my screen to start with the presentation. So you can see my screen now, right? Okay, the title for my presentation today is Finding NEMD. This is not Finding Nemo, it's Finding NEMD. NEMD stands for New Evaluation Metrics for Dialogue. This is a very important topic nowadays for the research community in dialogue. What I plan to do today with you is share some of my personal reflections on this topic. And the itinerary for today is basically very simple. I will be talking a little bit about chatbots first. Then we will move into metrics. Then we will see what's going on and some of the most recent works related to this topic, and then a little bit on how the future looks like. So some people claim chatbots can be probably the next big technological revolution. So I'm not sure whether this is the case or not, but definitely we can think about we as humans during the last 30, 40 years needed to acquire skills to use and interact with computers. So basically learning to use interfaces, mouse, touchpads, etc. So now it's like time for the computers to learn human language in order to be able to interact with those in the same way humans interact with humans. So the term chatbot is relatively new. The idea of computers talking to people has been for a while out there, but the term chatbot itself is very recent. So we can see it started to become popular in the late 90s, and actually the use of the term has grown exponentially, or more than exponentially, I will say, in the last 10 years or so. So, but if we look at the definition of chatbot, we can certainly say that the ELIZA chatbot, which was a simulation of a computer therapist developed at MIT in 1966, can be considered the milestone where the chatbot era really begins. So regardless the term being something relatively new, it has become an actual market revolution. Large tech companies, I mean the technological giants like Amazon, Google, Apple, and Microsoft, they all have their own branded chatbot. And if you look at the landscape, there is a plenty of companies offering services and products around the concept of a chatbot. This graph here is 4 years old. This is a study conducted in 2016. At that time, there were more than 170 new companies that collected around $4 billion in funding to develop new technologies related to chat. So we can distinguish 3 main types of conversational styles or systems: task-oriented, chat-oriented, and interactive question answering. And to understand the difference, we can see along 4 different dimensions, like in purpose. Task-oriented and question answering are more related to completing a task. In the case of task-oriented, that task is typically of transactional nature, while in interactive Q and answering is more informational tasks that we want to be completed. But when we move to chat-oriented, it's more like sustaining a meaningful conversation, type of chit chat or entertainment. There are not objective of tasks to be accomplished there. If we look at knowledge, both task-oriented and question answering, they require in-depth and specific knowledge about topics or domains. While in chat-oriented dialogue, we are looking more for superficial and broad general domain knowledge with a certain idea of common sense. I will be touching on this later. So when we look at, this determines how the systems are evaluated. So if we look at the success factors of these conversational styles in task-oriented and question answering, we look for task completion rate or response correctness. And typically we look for efficient interaction. So in few turns, or in the case of question answering, typically just a single turn or a couple of turns, the particular tasks should be accomplished. When we move into chat-oriented, it's completely the opposite. The more time the user is willing to interact with the system, the best. So we're looking for engagement. And finally, regarding to persona, in task-oriented or question answering system, we don't expect to associate some sort of personality with the system. So it's more like a professional and task-centered, no personal information share. In the case of chat-oriented, we expect the systems to be empathetic and friendly. So personal information and emotions are also shared between the user and the system. In today's talk, we're going to be basically focusing on evaluation of chat-oriented conversational styles. Most of the commercial system and chatbot that we're going to find out there are not specifically related to a particular type of conversational style. They typically combine different of these styles. But what we want to talk today is about the evaluation of chat-oriented conversational style. So finding NEMD is about a quest for evaluation metrics that are capable of assessing the quality of a chat-oriented conversational system. And there are a lot of challenges there. So first of all, dimensions of chat-oriented dialogue quality are not well understood. And based on what we saw in the previous slide, the different nature of chat-oriented dialogue with respect to task-oriented question answering determines part of those challenges. For instance, there is no explicit task or goal to be completed. Correctness and brevity are not paramount anymore. When we move to chat-oriented dialogue, basically we're moving from the informational realm into the kingdoms of opinions. So most of the time there are no right and wrongs. We expect things to make sense, but it's opinionated kind of communication most of the time. And there is some expectations of humanness from these conversational agents. And this humanness implies personality, implies they exhibit certain level of common sense and certain levels of intelligence. So, and this is the problem, when we talk about intelligence, basically, we are talking in the same lines of the Turing test. So what is a good conversation? We don't know in terms of automatic analysis. Definitely for humans, as we're gonna see later, it's very easy to determine this. But the main question here is that if intelligence is a necessary condition for having good conversations. We know we cannot measure intelligence, and Turing test typically tweaks this problem by focusing on intelligent behaviors. So basically the question is, should we measure intelligent behaviors? And are these intelligent behaviors a proxy for good conversations? So part of the problems of the Turing test is that it doesn't include the temporal dimension in the evaluation of the interaction between a human and an artificial entity. So this is a real example of a conversation between an automated system, a chatbot, and a human. So as you can see here, A and B interact. Basically, A is complaining about not getting a date and asking B to get a date. B agrees to okay, let's go for dinner. A replies that okay. B asks about some food preferences. A replies, and they agree on a time. So for this set of interaction, it's very difficult to tell apart who is the chatbot and who is the human. So we really have systems that can fool us in terms of making us think they behave like humans for a while. But the problem is that sooner or later, in most of the systems that are commercially available and that exist nowadays, sooner or later there will be a silly mistake or something completely wrong that definitely will break down this illusion of being intelligent. And part of the problem is that the level of abstract cognition faculties where these entities operate is very high. So typically for chat-oriented dialogue conversation, we're moving at an abstract high level of cognitive faculties that imply reasoning and understanding. And if we see how linguistics or the linguistic phenomena structures itself around the human communication scale, we will see parallels between the moving from a very low, let's say, physiological capability layer, which is mainly intended for communication means, up to the scale of abstract cognitive faculties that allows to pursue goals and intentions. So if we see linguistics in the bottom of this pyramid, we find phonetics, which is basically a system of sounds that allows to communicate. Then we have morphology and syntax, which are the rules for creating words and forms and combining those final words, forms into clauses and sentences. Then we have semantics, which is basically the way of conveying meaning. And finally, pragmatics, where we put this meaning into context and allows for meaningful conversations or interactions between humans. So when we talk about chatbot or chat-oriented dialogue, we are basically at the top of this pyramid. So let us talk now about metrics. So as we have seen before, evaluating chatbot is difficult. And if in the absence of useful automatic metrics, we need to rely on human evaluation. So what we expect from a good metric. So when we have a system, that system provides some outputs, and we can deem those outputs as correct or wrong. This can be in a binary fashion, or it can be a discrete scale, but we will basically will have systems providing correct or wrong responses. And what we expect from an ideal metric is that those correct outputs are mapped into good scores and the wrong outputs are mapped into bad scores. So that's an ideal metric where you will see a strong correlation between the ground truth and the metric score. But there are cases where we have wrong outputs mapped into bad scores, but you can find also correct outputs mapped into good and bad scores. And these are typically called pessimistic metrics. So to give you an example of this, if you think at blue in the machine translation case, blue behaves as a pessimistic metric because you know that blue basically compares the output of the translation system with a set of references. And if the output happens to match the translation references, then it will receive a good score. But there is the case of perfectly good and valid translations that doesn't match any of the reference. So in that case, a correct answer will be given a bad score, as well as wrong answers that are given bad scores. So blue in machine translation basically behaves as a pessimistic metric. We also have the case of optimistic metrics, where basically correct outputs are mapped into good scores, but we will find that wrong outputs can be mapped either to good or bad scores. And finally, there may be the case of a metric that basically can map either correct or wrong scores into bad or good, sorry, can map either correct or wrong answers into good and bad scores. And definitely this is a sort of useless metric. So if we see this is a study that has gained a lot of attention, and this is one of the examples where I think it is very important sometimes to publish negative results, because we can learn a lot about negative results. This is a paper that is entitled "How Not to Evaluate Your Dialogue System," and this is basically pointing towards the fact that humans seems to do well. So if you look at the left-hand side graph, here we are seeing how a set of humans rate some dialogues or evaluate some dialogues, and how this compares to the ground truth. The ground truth is also a human judgment. So basically what we're seeing here is agreement between humans in saying what is a good conversation, what is a bad conversation. So looks at this curve behave very clearly as an ideal kind of metric. It's not so ideal. We will see later that also there is a certain level of agreement. There is also some disagreement. I will be talking about this later. But when we move to evaluation metrics that use references, like in the case of blue, we see that blue that behaves as a pessimistic metrics. In the case of machine translation, it basically behaving here as a completely useless metric. And part of the problem is, and this relates back to my previous slides on the cognitive scale, that when we are in the bottom of that cognitive scale, applications like speech recognition, they have a very clear output that should be reproduced by the system. So basically, we are talking about one-to-one morphosyntactic matching between the reference words and the words in the output of the system. So basically, if the words are the same, we can score that output as good, and there is only one valid output. When we move up into the scale, and we go, let's put as an example again machine translation, then we still want one-to-one mapping, but now it's semantically. It's not like we want to see the same set of words. Basically, any combination of words that is a valid sentence and conveys the same semantics is a valid answer. So now we have a multiplicity of possible correct outputs that should be evaluated. And the way these scores deal with this is by incorporating multiple references. But if we go upper in the cognitive scale, we will find that in the case of chatbot, that semantic mapping is not one-to-one anymore, it's one-to-many. So basically, any semantics and any correct sentence can be a valid output as far as it makes sense within the context of the conversation. So basically, we have multiplicity of semantics, with each of those semantics having a multiplicity of possible options. So collecting so much references to represent that solution space properly is basically impossible. And this is why metrics that rely on reference similarity completely fail when we want to evaluate chatbots with them. So going back to the case of humans as annotators for quality metrics, as we saw before, humans tend to agree, but there is also some level of disagreement. And these are results from a previous evaluation. This is basically the inter-annotator agreement of human annotators over a 3-point scale for dialogue, or this is at the turn level, response validity at the turn level. This evaluation has 3 scores: valid, invalid, and acceptable. Valid should be answers that are correct within the context of the conversation. Invalid are answers that are completely incorrect, and acceptable are answers that are not necessarily correct, but that they make sense in terms that those are things that humans typically do. So if you think about asking somebody the age and the person just not answering the question, but trying to change the topic of the conversation, I mean, it's socially acceptable that people typically doesn't want to share age, and so such kind of response will be considered acceptable. So if we look at the inter-annotator agreement for all the annotated dialogue tones with the 3 scores, we will see that that inter-annotator agreement is relatively low. It's about 0.36 or something like that. But if we just kept a subset of the data that only include invalid and acceptable labels, which means we remove all the data that contains valid labels, we see even a drop in that inter-annotator agreement. And the same happens if we remove the invalid label. So we measure the inter-annotator agreement only on that subset of data that contains only valid and acceptable terms. However, if we remove the acceptable label and we just keep those samples that contain valid and invalid scores, we see a huge increase on the inter-annotator agreement. This basically means that most of the disagreement between humans concentrates on the intermediate class. So humans are good and they agree on the extreme of the scale, so saying what is really a good conversation and what is not a good conversation or a bad conversation. But in the intermediate class is where most of the disagreement appears. And this is possible because different cultural backgrounds or different appreciations. So we don't understand really what is the cause of the disagreement. It may be 2 reasons. So we can ask, do humans disagree because the task is difficult and confusing? Which means that the metrics are ambiguous? Yeah, that can be the case. But what about humans disagreeing because the task is subjective? And basically, those assessments are subject to personal preference. So having different opinions on when something is acceptable or not is okay. So I think it's very likely that we are facing a little bit of both scenarios, but this is still not well understood. So a much better understanding on the chat-oriented dialogue properties is needed. So looking at recent, this is a very interesting publication. The authors of this work, they did comprehensive exploration of the recent literature in chat-oriented dialogue, and they collected the different metrics that people is using nowadays when evaluating chatbots. So what we can see here from this long list, and there are more of those, is that there seems to be no consensus about the research community on what are good metrics to evaluate dialogue quality. So I'm not going to talk about all of them. I'm going to just refer to 4 of them because we will be talking about this later. So the first one is engagingness, which is basically to measure the capacity of the chatbot to keep the user interested and engaged into the conversation. Then we have humanness, which is basically how much the behavior of the chatbot is similar to the behavior of a human in the conversation. So this metric basically points in the direction of the Turing test, and it is also called sometimes human likeliness. Then we have sensibleness, that is basically whether certain response given the context of the conversation makes sense or not. And specificity, that tells whether the response is very specific or vague or general. An example of this is in the context of a conversation with somebody claims that I like ice creams. So a response like, oh, good for you, which is a valid in the context, is a generic, it's not a specific. But if the response is, oh, I also like ice cream, chocolate is my favorite flavor. So that will be specific because it's referring to the topic. And this metric happens to be very important because one way of avoiding errors in current chatbot technology is by being generic. So the less specific the chatbot is, the less risk that it is for the chatbot to make a mistake. But definitely, if you take this to the extreme, the conversations can be very boring because chatbots are always responding with very generic questions. Actually, you can build a perfect chatbot in terms of sensibleness just by using 4 or 5 answers like yes, no, why, or great, things like that. So the problem with human evaluations, and we saw all that metrics there in the previous slide, is that they are expensive. So recently there is this tendency to use crowdsourcing to speed up the annotation time and to reduce cost. But there has been always the question if we can really replace expert annotations with crowdsourced annotations. There has been several studies related to this, but most of them always conclude the same. So crowdsourcing annotations are not as good as expert annotations, but you can always reproduce expert annotations by combining multiple crowdsourcing annotations. So this is an example where we basically see the distribution of inter-annotator agreement between crowdsourced and expert annotations. When we compare the distribution to the agreement between 2 experts, which is here, you will see agreement between 2 experts is around 0.55. The distribution of agreements between crowdsourced annotations and expert annotations is biased to the low values. But very simple strategies like majority voting can help us to combine multiple crowdsourced annotations and bring the similarity of the combined metric, or bring the inter-annotator agreement of the combined metric to levels that are quite similar on how the experts agree. So finally, in addition to having multiplicity of metrics where we don't know which one is the best or not, I mean, there is no consensus on this, and also about having discussions between using expert annotations or collect more annotations by use crowdsourced forces. There are other dimensions in the human evaluation that we need to take into account. For instance, one of those is granularity. So should we annotate terms, or should we evaluate the dialogue sessions or the agents? So what you see in the literature working at different levels of granularity. And there is also the problem of modality. So interactive evaluation versus offline evaluations. In an interactive evaluation, the human judge is interactive with a live chatbot while performing the evaluation. In the offline evaluations, an independent judge sits down and reads a log of a conversation in order to make an assessment of the quality of the evaluation. So which of those are better, we still don't know. Let's move into what's going on nowadays. If we think about the last 10 years, probably, of natural language processing in general, without any doubt, the most important, or one of the most important achievements in the last few years has been the capability of building embeddings. So I will be talking in this session about 4 particular examples of the research work that leverage on the idea of embedding and deep neural networks in order to exploit somehow ideas to conduct better chatbot evaluations. I don't try to be comprehensive. I just selected these 4 works as a means to move in the discussion in the direction I want to move it. There is plenty of more work there that is quite interesting also. So let us first talk a little bit about embeddings. So as you already know, embeddings are basically byproducts of deep neural network training. So the embeddings are the internal representation, which is a non-sparse continuous space representation of language that the network builds in order to operate with it and solve a particular task. So natural language is indeed a very sparse representation and uses discrete events like characters, words, sentences, etc. And the embedding is the way neural network has solved the problem of creating a continuous space representation of the language in order to conduct operations with this. So, and this is possible because a very old concept that is called the distributional hypothesis, which basically states that meaning is determined by context. So these embeddings are basically representations of some sort of semantic representation of the discrete language, but projected into a continuous space. And one of the most important achievements regarding embeddings in the last few years is the possibility of building contextualized embeddings. In a contextualized embeddings, the particular representation of a word is not static anymore. It will depend on the context. So in a contextualized embedding, the representation for a word like running will be completely different, or different from running in the context of running a company, or in the context of running a half marathon, or in the context of running out of money, and so on. So let's go to the first example. This is a very interesting research work in which the authors, this is based on a sequence-to-sequence model with attention. So they built a chatbot, and they apply some control mechanisms, specifically weighted decoding and conditional training, in order to modify some of the attributes of the conversational agent. And basically, they focus on 3 of those: repetition, specificity, and question asking. It is well known that chatbots in general, at least this type of model, sequence-to-sequence models, they tend to repeat themselves within turn and across turns. And this deteriorates the appreciation of the quality of the chatbot. So reducing repetition helps to improve the quality of the conversation. The other problem, as I mentioned before, is specificity. In order to avoid the risk of producing wrong outputs, chatbots typically tend to be less specific and more general. So humans are typically more specific, and then pushing the specificity of a chatbot up is intuitively a way of improving the quality of the chatbot. And the other aspect is question asking. Typically chatbot, in a normal conversation, they ask less questions than a normal human will do in a conversation. So by using these control mechanisms to reduce repetitions, increase specificity, specificity and increased question asking, the authors evaluated by using human annotations for engagingness and humanness, the outputs of different chatbots where these variables have been controlled for. And when you compare the results of these scores with respect to the baselines that basically use greedy or simple beam search decoding, you will see that definitely there is a huge improvement in engagingness for when those variables are controlled for. And they are improving in such a way that when you compare to human performance, this is the evaluation for human-to-human conversation, this bar on yellow here, you will see that the engagingness basically reached a level that is comparable to the humans. That also helped in new humanness, because you see a significant increase in the humanness metric. However, it doesn't reach the level of humans. And interestingly, in this scale, if I remember well, the scale is from 1 to 4. Interestingly, even humans don't get the full score in the scale. But yeah, so controlling these variables help for engagingness, not too much for humanness, because we're still a big gap there between the current state of the art and the actual performance of humans. So in the second example, we will see more like how the properties encoded in embeddings can also be used to infer quality of chatbot performance. And this story is very interesting because this is based on two main assumptions. So the first assumption is that those pre-trained models implicitly encode dialogue quality knowledge. And this assumption makes sense because basically, as you know, when you train or when those models are trained, they are exposed to millions and millions of human-human conversations. So we still don't understand exactly how the information is encoded in those embeddings, but if they has been exposed to millions of human conversations, then there is a fair chance that the notion of quality is embedded in there also somehow. And the second assumption here is that follow-up utterances provide valuable information about the system response. So what the authors did here, they have crafted a collection of positive and negative follow-up. And a positive follow-up can be things like, this is interesting, or oh, I love this. And negative follow-ups will be things like, this is boring, I hate this, things like that. So what they do is to evaluate the quality of a given response. They use a pre-trained generation model, and feeding it with the context and the response, they predict the probability of generating a positive follow-up answer or the probability of generating a negative follow-up answer. So the score is basically the combination of log probabilities of producing positive follow-up utterances minus the combination of log probabilities of generating follow-up negative utterances. And they show in the study that when they compare to human assessments of overall quality, there are some correlations that are significant there. In the case of tune level, there are still low correlations, but in the case of the dialogue level evaluation, those correlations are higher. Going more in detail into the idea of exploring these probabilities of generation in the next example, I'm going to show the authors here look at how the perplexity of these generation models is correlated to measures of human likeliness. They claim that the human likeliness can be assessed by two different metrics that I talked about those before, sensibleness and specificity. But the interesting thing here is that those two metrics are not completely independent. They are interdependent. So basically, they ask the human judges to evaluate sensibleness first. And if the judges find that the response is not sensible, then they assume that it is not a specific. But if the response is sensible, then they go to the second question about the specificity. So those two metrics are not completely independent, and the combination of those two metrics, which is simple average, is called the SAA, which is sensibleness and specificity average. So in this particular work, they introduced Mina, that is a chatbot that has been trained with a huge amount of data. It's an end-to-end, large-scale, low perplexity generative model. And what they do is they train different versions of Mina that fit to a certain extent a set of test data, so they can measure the perplexity of the model in those different, in the text data for those different chatbot versions, and then they evaluate the SSA metric by using human annotations. So what they found, and you can see here that the blue dots in the curve, they represent the different versions of Mina, and what they found is that the perplexity of the system we're measuring the test data correlates pretty well with the human assessment on SSA. And for reference, they also compared the SSA for some of the most popular chatbots out there now. So this is a clear evidence that the embedding in this generative process also provides some information, because the probability of generating a particular sentence is somehow related to the quality of that response. So in order to explore this in more detail, 2 months ago during the channel workshop, the summer workshop, we wanted to explore this phenomenon in more detail and look into more detail what's happening inside those embeddings. So let's say you consider a sentence embedding of a dialogue corpora. So, and this example here is actual two-dimensional projection of a real embedding of a dialogue corpora that was basically extracted for human-to-human conversations from movies. So if you look at this and you think of a particular dialogue, you can think of a dialogue as a sort of random walk over that space. And those walks happen not to be so random at the end, because as we saw before, the probability of moving from one stage to the other are basically related somehow to the quality of those responses. So imagine, or let us consider the case when we compute some clusters on that space. If we do clustering, basically a dialogue can be represented as a sequence of transitions across clusters. And the question here, the main question is can we learn some sort of cluster engram model? Can we learn those transition probabilities, and whether those transition probabilities are basically useful in terms of automatic chatbot evaluation? So the answer is, well, it seems that yes. If we think at the dialogue level, and this is a very simple toy experiment that we did with the same data. So if we look original dialogues, well, we trained a cluster bigram model from that sentence embedding. And if we look at the original dialogues and we compute the perplexity of the model predicting those dialogues, the distribution of perplexity across those models is what we see here in blue. And when we do the same exercise from broken dialogues, and in this case, broken dialogues are the same original dialogues that we randomly replace a few turns with different sentences, you will see that that perplexity distribution will shift to the right, so towards higher perplexity. And finally, if you consider completely random dialogues, you will see that that perplexity shifts even more to the right. So somehow that perplexity is definitely responding to the quality of the dialogues in terms of how many random utterances we are incorporating in those dialogues. But this is at the dialogue level. The main point of our evaluation during the workshop was, can this will be a good predictor for quality at the turn level? So what we did is we take some data from the dialogue breakdown detection challenge. In this evaluation, what what we want to measure is the possibility of a breakdown in a conversation between a human and a chatbot. And breakdown is defined as a situation in which the response of the chatbot is such that the human finds difficult to continue the conversation naturally. So in the dialogue breakdown detection challenge, the conversations between humans and chatbot are annotated at the turn level with 3 different scores. One score is breakdown, when the breakdown condition happens. The other score is when a potential breakdown may be there, and the other score is not a breakdown, definitely. So what we did is we used the cluster diagram model that we trained on that previous sentence embedding that I showed you. And we tried to see how those cluster diagram models align to the average scores that are computed for the different dialogues at the turn level. And what we found is what you can see here in the graph. So it is interesting to see, of course, this is not behaving at all as an ideal metric, but it's interesting to see that for those turns that were considered consistently not a breakdown by the annotators, they tend to show lower perplexity. But for those turns that are considered dialogue breakdowns or potential breakdowns, we can find that they are assigned higher and lower perplexities by the model. So are we basically seeing here an optimistic metric? So is this useful somehow? Well, this is work in progress. We still don't know. We need to continue our exploration, but these look interesting and promising. So let me end by talking a little bit about the future. So it seems that next we need to move beyond semantics, but there is still a lot of questions that we need to answer and we need to understand. So what do we know so far? So we know that individually, humans seems to be able to easily tell whether a conversation is good or bad. They disagree at certain level in the intermediate categories, but humans seems to be good at that. So, however, the dimensions of chatbot-oriented dialogue quality are still nowhere understood, and the proof of that is when you look at the literature, there is a lot of different metrics being proposed out there, and there is no consensus about what is a good way of evaluating chat-oriented dialogue quality. And what is definitely everybody's convinced at this now, traditional reference-based evaluation metrics have amazingly failed to assess chatbot quality, and that has to be with the level of complexity of the cognitive scale we need to go up in order to do those assessments. So, however, regardless that, it seems that we are reaching a point in which we are able to build impressive chatbots. So the main question here is that true, or are we really mastering the art of building super parrots? So, and that's still a problem of intelligence, that we need to learn more about how to assess or understand intelligent behaviors. So what do we need to do to move forward? So rather than answers, regrettably, I'm giving here more questions. So basically we need to decide or understand whether should we focus on reducing disagreement or accepting disagreement and personal preferences as a valid aspect of evaluation? Should we focus on considering multidimensional or hierarchical composite evaluation scheme? So remember our sensibleness evaluated first, and then if it is sensible, the response moving into specificity. So that's a sort of hierarchical composite evaluation scheme. So should we focus on building more complex of those schemes, or just evaluating different metrics and combining results? Should we focus on addressing different levels of granularity, like turn, dialogue, and agent jointly or independently? Should we focus on using expert human judgment or the wisdom of crowds? Or should we focus on conducting offline or interactive evaluations? Well, for each of these questions, we can talk for hours. I'm not gonna go into details, but There is only one particular aspect I want to discuss a little bit more because I find it really, really interesting, and it's related to the last two questions. So imagine we take expert human judgment in an interactive evaluation mode, and we take this to the extreme. So imagine expert interactive evaluation taken to the extreme. This will bring us to a very, very interesting concept that is called the chatbot psychologist. So in a series of articles in medium.com, Eric Sound developed this idea. He focused more on robot psychology, but he devoted the last of the articles to reverse engineering conversational agents. I really suggest you to go and read those articles because they are very inspiring and motivating. So all this is based on the idea of the theory of mind. The theory of mind basically explains the fact that when we interact with, let's say, animated entities, we build in our mind a model of the other entity mind. And we use this on a daily basis. So we assume or we assign minds to the entities we interact with, and we do inferences about that other party mind based on the way they respond to our interactions and as we know them more and more. And this theory of mind basically drives how we handle interaction with animated entities. And a very simple example of this is we completely conduct different behaviors and interactions when we communicate with a 10-year-old child, or when we interact with an adult, or even when we interact with a baby. Even when we interact with a dog, our behaviors and our expectation of the dog is different, and the way we communicate with dogs is completely different. So for every animated entity, we have the ability to interact with this theory of mind comes into place in order to make us assumptions and understandings of how that other entity works. And when we interact with chatbots, something of this may be happening. So is this happening actually? Well, we don't know, but I will assume yes. When I see my daughter that is a teenager interacting with Siri or Alexa, it is clear that she's talking to these devices in a different way. She communicates with other people, and because the younger generation, they are basically understanding how to use those devices and how the logic behind it is. And the idea of chatbot psychology is very powerful because, in my opinion, those embeddings we are building and those deep language models, they are still not well understood. And the same way psychologists interact with people to understand what is inside the mind of the people, chatbot psychology can also discover a lot of information about those relationships and those things that are encoded in those embeddings. And this can give avenues to understanding design errors and also to improve the quality of the chatbots. So this is a collective effort. There is a lot of venues, resources, competitions, workshops, and so on out there. I want to finish by talking just a little bit about the Chanel workshop that happened just 2 months ago. And this workshop was basically, this was a summer workshop within the framework of the Johns Hopkins University summer workshops. And this workshop was about chat dialogue modeling and evaluation. And there were about 27 participants from more than 10 institutions around the world working for over a month in certain topics related to this. And for the group that work on chat-oriented dialogue evaluation, the main achievements or the main focus was on corpora collection, pre-processing, and feature extraction, as well as some metric definitions and human annotations and collections. And all these resources, some annotation is still going on. There is a plan for continuing this workshop. So some of these resources are available, and there is a lot of opportunities here for collaborate in the future. So some final remarks. Finding NEMD is still an open problem. The good progress seen so far seems to suggest we are getting closer to a solution. And if you if you are better in this field, probably you know this already, but if you are new to this field, so let me tell you that these are times of unprecedented opportunities for getting involved in the field and making a contribution. There is plenty of information, data, and resources available. So this is a great time to work in this. What we see in the next few years is that this area of research will basically revolutionize the way humans interact with computers. And I have this appreciation that we are just sitting at the top of the iceberg. So the best is yet to come. So thank you very much for your attention. I would be happy to take questions if there are questions.
So thank you very much, Rafael. This was really an epic journey to this finding and NEMD new evaluation metrics for dialogues. I think there are many questions, and now I'd like to ask everyone to use the chat, as I said, in the chat button at the bottom of your screen. So please send your questions to all, everyone. And because of the short time, I will then read the questions and also the name of the person who asked them, and then Rafael can answer to those. So please use the chat and write very sort of clear questions and succinct, short, clear questions. While you are probably thinking of those questions, so maybe I can start meanwhile and asking Rafael about these personality issues. I think that was a very fascinating thing to think about, not only about these psychiatrists, but also the personality of the chatbots. And my question is that doesn't that kind of give way to different types of evaluation and people's opinions, because people may be attracted to different types of personalities and they like different types of ways to discuss and provide information. So there you may not have only one single evaluation metrics, but you need to also take into account the personality of the interactive chatbot.
Yeah, thank you for the question, Kristiina. I think, yes, this is a very important point. I mean, we tend to think about chatbot as entities that behave all the same in the same way all the time. So evaluation metrics, something fixed about particular dimension. But yeah, one of the main areas of research in chatbot now is empathy. So how you build a chatbot that can get the attention of particular users by using these techniques like rapport or feeling identified with the person. And definitely, if we move in that direction, evaluation is also has to align in those directions. Probably it's not the same evaluating a chatbot that is talking to a person in a particular, is talking to a person about a particular topic that is of interest of the person and the chatbot, whether it's talking with the person about a completely different topic or is performing a different task. I think part of the challenges is not only being able to properly evaluate chat-oriented dialogue, but how you embed that evaluation into a conversational agent, which is a more complex system that involves different conversational styles and can behave differently when you target different people.
Right. Yeah. I was thinking that also one important thing about the personality is the appearance of the system. So we may think about something like speaking heads, etc., but maybe also some kind of a small robot type interactive agent is also coming on the markets, and then this type of appearance can also be kind of included or can also affect how well the interaction goes on. So there are many questions or many issues related to that.
Yeah, I found the robotics area even more fascinating because in the case of chatbots, there is not physical context being shared. I mean, it's more about information and knowledge. When you move to robotics, in addition to that knowledge and information, mutual context between the entity and the user, there is a physical context where the location of the robot, the things they are seeing, the different, the richness of the communication that can happen in such an scenario is even larger than what happens just in a screen.
Right. And now there is actually one question from Asier. So I'll read it to you. I found very interesting the Ngram graph stuff for evaluating or analyzing the progress of dialogue. You were computing the sentence embedding for that, right? How were you computing those embeddings? With the same model that was producing the responses? Thank you for your talk.
Yeah, well, thank you. This is a very interesting question. Yeah, those embeddings are internal representation that these models build. We try with different, if I recall properly, we try with different embeddings. Some of those using BERT and the others with the dialogue in GPT. And yes, those were sentence embeddings for the corpora. We trained embeddings with all the corpora, but we learned the cluster Ngram probabilities with a training set, and we evaluate those perplexities on whole of test sets. So that was basically the procedure. There is a lot of details. We are documenting this better because there is no paper related to this. We did this just a couple of months ago during the summer workshop. There is a lot of implications on how many clusters to use, how to fine tune the parameters of the models. I mean, as always, there is a lot of detail in there. We will be documenting this properly, but that's the basic idea.
Okay. And now there is also a question from Luis. So I'm surprised about that PPL shows a high correlation with the chatbot evaluation. However, how to avoid that the chatbot in providing general responses that just show low perplexity? And what about your feeling to include knowledge into the answers? What should we expect for future? Thanks.
Well, thanks for this question. Yeah, those are open topics, I think. Yeah, the inclusion of knowledge has been always a problem. I mean, we're including knowledge in the form of embedding, but how you integrate this sort of continuous space representation of knowledge with a more formal storage of knowledge, like databases and knowledge graphs. I mean, there is a lot of people working in that direction, how to combine or represent these two things simultaneously. I really believe on hybrid systems. In my opinion, the way the human mind operates is similar. I mean, there are questions that we automatically reply without thinking too much, something we store in an embedding. But there are other questions that we need to stop and do some reasoning before answering. That means we, in our mind, are operating in a completely different way. Yeah, and those perplexity correlations were seen in the world that we saw that perfect correlation. Those evaluations were done at the agent level. So that's the correlation of perplexity of the model with all the conversations that model had with the annotators. I think the challenge here is, I mean, it is clear that those embedding encode information that allows to infer based on those probabilities, the quality of the dialogue somehow. But I think the challenge is to move to the turn level, because if we are able to detect quality trends at the turn level, then we have an automatic way of implementing self-correcting strategies for the chatbot. So the chatbot can realize that was not a good answer and try to somehow resolve it, or even before giving the answer to switch a strategy based on those scores. But that's a challenge. I mean, it's not a trivial problem.
Okay, thank you very much. We have now 2 more questions, and I think we are sort of running out of the time, but I'll get these 2 questions to Rafael. So if you have any more questions, then there will be certainly other time later on. We will keep the Zoom channel open if you want to talk and chat a little bit more. But now there was one question from Marina Escobar. Do you think that a chatbot that behaves with a bias, what should be avoided from the developers, would be perceived more like a human? Thank you for your talk.
Yeah, well, that's an interesting question. I don't feel I have a convincing answer for that. Probably yes. I mean, part of this is related with what I mentioned before about the Turing test failing on specifying the temporal dimension of it. I mean, humans are very versatile in changing topics and the way they interact. Part of the problems with chatbots, when you interact with them for a while and you're really convinced, wow, this thing is intelligent, then there is some silly mistake, some error that really surprise you. So I don't know if you read the example there in the psychology slide, where if you ask to Alexa, like if the Star Trek a pineapple, and it clearly say no, Star Trek is not a pineapple. But if you put this in a different context, is Star Trek a pineapple? It makes it say, well, I don't know. How you don't know? I mean, if you answer right first time, why not now? So I think part of the problem is there. I mean, the shadow strategies ideally should not be fixed. They should somehow adapt to the conversation, and that will give a more perception of intelligence from the human side and better appreciation of the quality of the dialogue. I don't know if this answers the question, but
yeah. Well, thank you. And as I said, we have time to sort of continue this a bit more. So the final question is from Jokinen. So, hi, Rafael. Thanks for the optimistic and inspiring talk. Related to Kristiina's points and your response, do you know if there are plans to measure the effect of the appearance of the agent in the evaluation of dialogue? For instance, whether age, ethnicity, animation effects of agents have an impact on humanness and sensibility scores from human raters?
Yeah, thank you, Kenhui. Nice to hear from you. I mean, this is an interesting question. Well, I don't know. Yeah, I mean, I think that's a philosophical question. Do we want to interact with chatbots in the way we interact with I mean, we know they are not humans, they are computers. And I mean, it's like when you interact with dogs or other animals, you have an expectation of the intelligence and you learn to interact with them, and you can have a good relationship with pets and so on. But trying to make chatbots more and more human-like in so many dimensions, that may become scary. I don't know, there is this design idea, and this applied to robots, when the thing is so close to a human being, it lost the attention in terms of something nice. It becomes like something really awkward or creepy. So yeah, I don't know whether we want to go in the direction of making chatbots more and more similar to humans in those different dimensions. But that's a really interesting question, and I think it's more like a philosophical discussion.
Right. I think it's something like boundary crossing agents. We are here sort of trying to go to the other side. But anyway, I think we all now want to join. Thanks, Rafael, for this very good and inspiring talk. And there will be some time later on to talk to you more. But I will now give a floor or screen to Luis. So thank you very much.
Thank you very much.